Hello. So, as Yarden said, my name is Aviv. We're going to talk about the tragic death of inheritance and the lack of inheritance in Go, specifically. Before we start, a word about me. I am the head of platform at Human Security. I'm a strong advocate of the Go language. Among other passions, I have a strong passion to learning and analyzing and comparing the different traits of different programming language. I write about it at my blog alongside other topics. You can follow me there. Also, for those of you who know, I'm the author, the co-author of JavaScript. No, please don't. Okay, so the story of this talk is really the story of me getting into the language. It wasn't a all easy journey for me. Now, don't get me wrong. I loved many things about the language right from the start, but some other aspects were harder for me to agree with. Specifically, the structuring and modeling of code. With the emphasis on lack of inheritance in the language. So a word about my background. I came to Go 6 years ago from a diversity of languages. I used to write a lot of Java and JavaScript and Python and C# and PHP and others. And what all these languages have in common is the fact that they all support some level of inheritance and abstract modeling. Go, as most of you probably know very well, doesn't allow any of that. So for those of you who came from a similar background like me, for those of you who did used to write inheritance, for those of you who kind of miss inheritance, can you raise your hand? Let me see who you are. Okay, not many of you. For you guys, you might find your journey and my journey kind of similar. For the rest of you who didn't raise their hand, this talk is going to cover simplicity in code modeling in general and might suggest a way of wrapping your head around why I think Go's philosophy is better than other languages. So after 4 years of extensive Go coding, and even while being a main figure in designing a developer experience for my company as a principal architect and various other roles, I'd still argue for inheritance. I'd initially, like in the first 1 or 2 years, say that inheritance is probably a better choice. Then I went through a phase of saying, inheritance and composition are both valid means to an end, but that I personally preferred inheritance. And then finally, after having written Go for almost 4 years at the time, I was like, okay, composition is better. I get it now. And I want to share it with you because I think it can be very helpful. So in the rest of the presentation, I'm going to explain why I think this is the case, composition being better, and why did it take me so long to get there. So let's start with some background. Let's explain what composition and inheritance are. Now, it's not an easy topic to cover because there's no clean cut where composition ends and inheritance begins. There's a lot of gray area in between. The Wikipedia page for composition over inheritance does a very good job in just making you more confused and miserable. It says classes should favor polymorphic behavior and code reuse by their composition over inheritance, blah, blah. Okay, we need a simpler explanation to get to the bottom of this. So let's start at the beginning. Why do we need composition or inheritance to begin with? So mainly to avoid code duplication. As Wikipedia tried to suggest, it's about being able to reuse code without duplicating it. Code duplication create error-prone code bases. The more code duplications you have, the more likely you are to break things up. So composition and inheritance are two different tools to eliminate code duplication. While inheritance is being about hierarchies, composition is all about composing building blocks. To be a bit more computer sciencey, inheritance is a relationship between components, and composition is about has a. So inheritance would claim that a dog is an animal, while composition would probably argue that a dog has animal behavior. Let's take an example for this discussion to start making sense. We would work with this example throughout the entire presentation. Note that in order to be able to express inheritance, we won't be able to use Go. So the code snippets will be in pseudocode. Do not get tempted to think this is TypeScript, because I got very lazy at times, so this is not valid. So in the code snippet in front of you, you would see the animal interface being implemented by 3 different classes: dog, cat, and bird. They all do quite the same thing, but they speak differently. If you look at the code, you would see dogs go woof, cats go meow, and so on. Aside from that, there's a very apparent code duplication that we want to eliminate. So let's see how inheritance help us eliminate this code duplication. We would typically create an abstract class. We create the shared logic inside the doStuff method, and then we create an abstract method for speak, making the 3 classes that we want to actually create, the child classes, they have to define the speaking behavior. Now, obviously, inheritance has many different solutions to this problem. However, this is a rather typical approach. Moving on to composition. Composition would probably do something like that. We create 2 common functions, consume energy and rest, and then dog, cat, and bird can call these common functions, and in between implement the unique speaking behavior. Now, since composition is not as structured as inheritance, it has a wider variety of approaches. However, this is probably the simplest composition solution. If the language offers higher order function support, meaning functions that can receive other functions as parameters, like Go does, you can also go with this direction, create a single shared common function, and do this. Now, since inheritance and composition are 2 completely different programming paradigms, they create different coding structures. When you get to seeing one of them, the other may seem kind of confusing or weird. Shifting between them requires kind of a mindset change, and trying to mix them up, inheritance and composition, may lead to something you're not pleased with. So let's start with my journey. The first phase for me was, nope, no way. As someone who came with a fair share of experience with object-oriented programming, composition initially seemed to me like it simply doesn't solve the problem of code duplication. If you look at the inheritance code on the right, you would see it looks cleaner. Each component contains the bare minimum code to specify its deviation from the default behavior. If you would see, it only defines the speaking behavior, doesn't have to do anything other than that. If you look at the other side, both composition examples contain some level of code duplication. I marked them in red lines. Furthermore, inheritance requires some level of syntactic support from the language. The language must allow inheritance to exist, otherwise you simply can't express it. For composition, you just write functions that call other functions. It's funny that we've bothered naming it, right? It's just basic programming, writing functions that call other functions. Now, as someone that, this was pretty annoying to me, because as someone that's used to seeing complex syntactic structures, completely eliminating code duplication to suddenly just see basic programming, which leaves at least some amount of code duplication in the code, I took a hard time seeing it as a step forward. And now we move to my second phase of internal debate. So as I started seeing more and more Go code, I started seeing more and more composition, and I had this kind of mental shift to start making sense out of what I'm seeing. It also helped me seeing the problems with inheritance. Now, before we move on to the problems with inheritance, let's talk about the importance of readability in professional code bases. So I believe that code should be easier to read than it is to write. Every professional developer should know that you write a line of code once and then maintain it for many years. By a show of hands, who can identify with this sentence? Okay, that's many, that's great. So just to be clear, some lines of code may change 5 or 10 or even more times during their lifetime, but any line of code is probably being read dozens of times per day, obviously depending on the size of your code base and the size of your team. Let's say we have a line of code that's being changed 100 times during its 5-year lifetime. You only need to take a look at it a couple of times per week for it to be more read than being written. It's very obvious to us when we design database access that we consider rate and use cases of reads versus writes, and we optimize accordingly, right? If we're going to have many more reads than writes, optimize reads to be more efficient. Why aren't we doing the same thing with our code bases? Does that make sense? Now, obviously, I'm kind of preaching to the choir here because you're all gophers, and that's kind of what the language is all about. But hopefully, the ones that were kind of on the fence, I hope I could kind of convince you. And with that, let's move on to the actual readability issues with inheritance. So by nature, inheritance is a bottom-up approach. If you wanted to figure out the behavior of the do stuff method of dog, which is what you see on the top, you would go into the dog class, but you see soon enough that you have to start going up the hierarchy and understand the behavior of abstract animal to figure out how exactly it interacts with its abstract methods, and then start going up and down the hierarchy to figure out which methods are being overridden and at what level. Now, this is extremely demoralizing, extremely annoying, especially when you're not the one who wrote this hierarchy. And the deeper and more complex the hierarchy is, the more you want to get into shower and sob uncontrollably. By a show of hands, again, who can identify with that? Who's seen object-oriented code that he regrets seeing? Okay. So many of us have those bad memories, but this is not per se the problem, because the popularity of code bases containing bad practices in object-oriented is probably mostly an indicator of the dominance of object-oriented programming in recent decades. We can just as easily abuse composition to the point that it's unreadable. Instead, I just want to acknowledge the fact that composition is simply a top-down approach, making code more readable. Composition manages control flow by the function call on the actual call site. Meaning, if you want to understand dog.doStuff, you simply go to dog.doStuff method, and then if you need, you can start traversing down. For inheritance, having to search the hierarchy up and down can be very demoralizing. And if you add real-world examples to it, if you want more features, if you want to debug concurrency issues, if you want to understand edge cases, if you want to reason about the behavior of the program, it becomes exponentially harder. Another problem with inheritance is that inherited code is less dynamic by nature, and future changes may require much more effort. What do I mean? Let's see an example. Let's say we want to add some behavior to dogs. Right after they eat and just before they poop, we want them to get a treat, right here. Now, this is an actual photo of my dog asking for a treat after he finished eating. This is an actual face saying, dude, where's my treat now? So let's see how we do that. So with composition, it's a very simple, very easy task. We go to the dog class. We need to skip the common function and call eat and poop directly. And then we add the call to get treat. Done. We're finished. With inheritance, on the other hand, we have to do this, meaning we have to create a new method for the abstract parent. We have to name it something. We have to call it, and then and only then we can override the behavior from the dog class. Now, it might seem simple and easy enough, but do not underestimate the implications of this. This is not always trivial to figure out the best implementation for such requirement. Where would you break the ancestor behavior to allow for this change? Are you able to implement this change only by changing dog and abstract animal, leaving the rest of the classes, cats and birds, unchanged? What would you call this method? Is do stuff in between eating and pooping a good name? Probably not. How about get treat? Is it better? Isn't it too specific to dogs? Because dogs get treats, cats and birds, something in the future might do something in between. It probably won't be getting treat. So in real-world scenarios, base classes like this have so many non-trivial breaking points to support for their child classes that the whole thing becomes unmaintainable, unreadable. Another thing is performance implications. Do we actually want cats and birds calling random function in random places just for dogs to be able to get their treats? Isn't that kind of weird? So I know there's a lot of compiler optimizations that may help, and most use cases will not be interested in this level of performance, but many cases definitely are. And it might be a big deal for them, and this seems like a funny thing to be dealing with. Now, let's dive into the maintainability issues with inheritance. Let's see the impact some requirements may have as your product scales and as your code base supports more and more features. So what you see is how we started. This was the initial code of inheritance. And then we got a new requirement for dogs to get treats. And this was our implementation. Next, let's say cats should get catnip between sitting and sleeping. Note how we have to make changes in at least 2 places. It was the case for dogs. When we needed to change dogs, we needed to do a change in the abstract parent and in the child class. Same for cats. This is due to the bottom-up approach of inheritance. And then let's say mammals should be able to consume milk when they're young. So a typical inheritance approach would be, let's create an intermediate class only for mammals. Let's have dogs and cats extend this new class, and then we can overwrite the eating behavior. And finally, let's say we want to allow birds to fly between speaking and sitting. Now, if you look at the final code, specifically for abstract animal, you can see that it's very hard to follow. And it's just simple example. There are 3 layers of hierarchy, but it's applied only on a portion of the hierarchy. The base class contains so much breaking points to provide for custom behaviors for the child classes. It's very hard to follow and understand. And in real time and in real life, it's much more complex than this. Now let's see the simplicity of composition in action. This was the code we started with, and this was our solution for dogs to get treats. Now let's say cats want to get catnip. Again, very simple code change. Note at this point how we only have to change the class itself. So when we needed to change dogs, all we needed to do is touch the dog class. Now all we have to do is change the cat class. Moving on, mammals should be able to consume milk. So we create a common function for mammal eating, and then we call it from dogs and cats. And finally, birds should be able to fly. This is a single line change. Note at this point how the final code looks like. Isn't it much more easy to understand? Each class is doing exactly what it should. There are no extra layers of complexity. Everything is simple and straightforward, easy to understand. And most importantly, while we needed to make those changes, we didn't need to think of special method names and see where in the hierarchy we needed to change them. Each change was very trivial, simple, and quick. And with this, we're moving on to the last phase of my journey, the acceptance. So being the selfish person that I am, this realization hit me not while writing my own code, but while reading my peers and reviewing them. Obviously, when I write my own code, I want it to be perfect. I want it to be beautiful without duplications. I want it to be elegant. But that's the thing that's fully hard to comprehend is the fact that when we write code, we hold so much knowledge and context in our minds. When we read code, we simply don't have this level of context. So everything seems much more complicated than it is. Have you ever gotten ownership of someone else's code after they've left the company? You scratched your head asking, why? Why did you do it? Like the guy in the, yeah, he probably got someone else's code. So to me, it happens even if I admire that person. I look at someone else's code after I can't help them, I can't ask for their help. It always seems too complicated, too hard to understand. So who's right? The person writing the code saying it's easy enough, they should understand, or the person reading it going, it's too complicated? So according to readability over writability, the person reading the code is the one we should listen to. And this is actually the solution. When you write code, pretend like you're smarter than anyone else who's ever going to read it. Help them understand the code by writing something so easy to read, so silly, that they can just understand like this. Now, obviously, in most cases, you're not going to be smarter than everyone else, but for me, this kind of mindset really helps me write code that other people, including my future self, can easily understand. I'm fine with some level of code duplication as long as it's well intended and it helped me write a straightforward top-down code that I can read and immediately understand the author's intentions, the outcome, the concurrency implications, and simply remember that I actually do admire them. In some ways, I expect experienced engineers to write code that resemble that of someone new to programming in general. The more experienced you are, the less tempted you should feel to take the fancy solution to a problem. Now, before I leave, I just want to leave you with some final thoughts. According to GitHub stars, which is one way of measuring language popularity, it looks like classic object-oriented, like Java and C# are showing signs of passing their peak period, and languages that lack inheritance, like Go and Rust, showing a consistent increase. Now, this might be an indication that the programming community is saying we want to go towards the direction of composition. It doesn't mean inheritance in itself is a bad idea. It might be a good solution for use cases where taxonomy is actually a perfect modeling of real-world issues and problems. But in all other cases, composition would be the better approach. On the personal level, it took me a long time to get there, but I found a lot of peace in understanding this. As professional coders, delivering actual business value, we have to ask ourselves, what's more important? Writing beautiful and elegant code, or writing code that others will be able to easily understand and maintain? That's it for me. Thank you. Before I move to questions, I just want to mention quickly my beloved company, Human, where we safeguard the internet and handle huge scales of traffic and massive data, and we do most of it in Go. And we have the best humans. So if you want to connect, let me know. We need new people also in my team, and we love to talk. That's it. Thank you.